All right, I'm going to review the important aspect about wave. All right, so the important properties. So one, wavelength, which is the length of one cycle. You can measure from here to here, top to top, bottom to bottom. Frequency, which is the number of cycles per second. So let's say that's 1 second. They are 1, 2, 3 cycle. So there's a 3 cycle per second, right? So per sec, that's the unit of frequency, or we just call it hertz. Okay, which is a scientist name. And the wave that has low energy, so they also have low frequency. High energy also have high frequency. And the energy and frequency are inversely proportional to the wavelength. So low energy, long wavelength, high energy, high frequency, short wavelength. Okay. And hold on. Okay. All right. Now, the math review is really important. Some people have a problem with math. That's why we're going to talk about today. So, James Clerk Maxwell relate the frequency and the wavelength. So we have this equation. Yeah. If you know wavelength, you know frequency. If you know frequency, you can calculate for wavelength. Max Planck, the wave guy, relate energy to the frequency, right? And we can tie this equation with Maxwell equation. So you can relate energy to the wavelength. All right. All right, let's do this together. So I'm just going to go through it. I suggest you pause the video, do on your own first. If you stuck somewhere, don't worry. I got you right here. All right, a beam with blue light has a frequency of that frequency. What is the wavelength? All right, frequency and the wavelength, with which equation are you going to use? Well, of course, it's going to be that. There's only one equation that relates frequency and a wavelength, right? So if we are looking for, we want to calculate the wavelength, so we need to know the frequency, which is given, and the speed of light, which is constant, also given. All right. Now to do that, I have to rearrange this equation real quick. So I'm going to time wavelength on both sides. Basically, I just move wavelength to the left side. Okay, and the rest just plug in, guys. So the speed of light, that number, and the wavelength is that hertz. Right. Now, I mentioned before, so always keep the unit. But when you do a calculation, hertz, you have to convert hertz. Convert hertz to per second, so you can cancel out per second. If you leave this with hertz, and you probably don't forget about hertz is actually per second, right? You can't cancel them out. So make sure you well, it just makes things easy. Convert hertz to just per second, which is they are exactly the same unit, right? All right, per second and per second, cancel them out. And the last unit should be meter right there. All right, that's a unit of wavelength. You should get that. But are we done yet? No. The question asks you for a nanometer, which is a popular unit of wavelength. So convert that. We have meter, so we're going to put meter at the bottom, nanometer at the top. 1 meter is 10 to the 9th nanometer. So meter cancel out. Do the math right there. You get that number. 3 sig fig, 1, 2, and 3. So 3 sig fig, 4, 6, and 8, and round them down. And you get the answer. Okay. All right, this one a little bit longer. So what is the wavelength in nanometer of a photon with an energy? So we have energy, all right, to wavelength, and what color? We can talk about color later. All right. So we want to find an energy. We have an energy. We want to find a wavelength. All right. In these two equations, energy and the wavelength are totally in a separate what's it? And what do they call value? I mean, they don't relate, right? But we can relate them. What's the link between energy and the wavelength? The frequency. There's a frequency right here, which means that we're starting out with the wavelength, so you can find the frequency. And if you know I said wrong, sorry. We start out with an energy. From energy, use the first equation, you can find I said wrong again, turn around. We start with the energy, right? Once we have an energy, you know the energy, you can calculate it for the frequency. And once you know the frequency, use the second equation to calculate for the wavelength. So there are 2 steps there, all right? So the first step, so we're gonna calculate the frequency first. I'm going to move things around real quick. So move h to the left side, or divided h on both sides, or whatever, same thing there. All right. So you're going to have nu equal to E over h, and then plug in. E is 3.75 times 10 to negative 19 joules. and H is given, which is the constant 6.6 blah 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 right there. All right, do the math right there. Joule cancel with joule, you're gonna be left with the unit of per second, which is the unit of frequency, hertz. Okay, do the math right here, you get that. Don't round them off yet, because every time you round off, you add the uncertainty to your number. We round off just one time at the end. Okay, so I'm gonna keep number, but keep in mind this is 3.6 fixed, 3.75, so 3.6 fixed. Okay, all right, now we have the frequency. Now we're gonna calculate for the wavelength. All right, so use a second equation. I'm gonna rearrange this, so times lambda on both sides, and put and divide nu on both sides. You should get this equation. All right, and then I'm gonna plug in. All right, so the speed of light is 3 times 10 to negative 8 meter per second, and nu, the frequency we just calculated, 5.6595, whatever that is, and per second cancel out. Do the math right there, you should get that meter. Okay, not done yet. That's not a nanometer, so we have to convert that to nanometer. So put meter at the bottom. They will cancel out later. 1 here, 10 to the 9th nanometer. Meter cancel out. You should get that number. All right, last one. So this is 3.6 fixed, so only 530. Write them down. Okay. All right, we're not done yet. This question asks, what color is this light? Well, we're gonna look back at the chart. Okay, 530 nanometer falls into the visible light region. 530 is right there. Yeah. All right, one more time. So pause the video, do on your own first, and if you're done, I'll just check with me. A photon has a frequency of that hertz. What is the wavelength in nanometer and an energy in joules? All right, so we have the frequency. Well, easy. Frequency, you can go anywhere, either one. So frequency you can find the energy and can find the wavelength. To find energy, we just use that equation, right? Relate the energy and the wavelength, and frequency. And frequency, you can find the wavelength using that equation. Okay, so 2 steps here. 1 step finding energy, the other one finding wavelength. All right, start with the energy here. So plug in H is given, which is a constant, Planck constant, and frequency is 7.5 times blah 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 per second. All right, same thing here. So try to convert a hertz to per second. They are the same unit, but if you put hertz right here, it won't cancel out with that second. All right, if you do per second, so second per second cancel out and get joules. All right, so this is 3.6 fixed, make it 3.6 fixed. Round them up. Let's round it up. So 4.97. Okay. All right. Find wavelength. All right. So wavelength right here. So we're gonna move things around. Rearrange this equation. All right. Wavelength equal to C over nu. So now plug in C 3 times 10 to the 8th meter per second. Frequency, not wavelength. I got confused all the time. So frequency 7.50 times 10 to the 14th per second. Per second cancel out, and the answer right there. Okay. In nanometer, so convert that. I put meter at the bottom, nanometer at the top. 1 nanometer is 10 to the negative 9 meter. You can do that as well. Or you can do 1 meter here, 10 to the 9 nanometer. They are the same thing. Meter cancel out. You should get 400 nanometer exactly. All right. So what's the color? Look back to the chart. 400 nanometer is right there, about violet. Okay. All right. Now let's start your turn now. So class activity number 1, we have question 1 and question 2. Okay. All right. Let's go to the next video.